Hello students, welcome to the next video on Analog Electronics 1. Myself Gunjan Mittal Roy in the Department of Electronics and Communication Engineering in GEMTech, Greater Noida. In this video, we are going to discuss about Class B power amplifier in its push-pull mode. So which is Class B push-pull power amplifier. So what is basically a Class B power amplifier? In a Class B amplifier, the Q point lies exactly at the cutoff axis and therefore we get the current only for the half cycle of the input signal, and this is the biggest drawback of this amplifier, whereas the best part of this amplifier is that it offers maximum power conversion efficiency of 78.5%. This is the Q point graphical representation showing us that the Q point is lying exactly at the cutoff axis, due to which the half of the cycle is only obtained at the output and the remaining half is cut off. So the conduction angle is only 180 degree and the current flows for only half of the cycle, or the voltage appears is only for the half of the cycle. So this is the biggest drawback. Now we can overcome this drawback by having a configuration which is called as the push-pull power amplifier, where we use two transistors. This is showing us that it offers a maximum power conversion efficiency, which is why it is the most widely used power amplifier. This efficiency is 78.5%. So it is such a big efficiency that it is widely used. And efficiency is not the only parameter. The other thing is the overall full cycle that we can obtain with the help of a configuration called as push-pull power amplifier. So here is a push-pull power amplifier having two transistors T1 and T2 connected in such a way that both the transistors, or one transistor amplifies half of the cycle and the other transistor magnifies another half cycle. So we can say that the one transistor pushes the signal and the other transistor pulls the signal, and that is why it is called as the push-pull configuration. So along with the two transistors T1 and T2, it has got two transformers TR1 and TR2 and a biasing voltage VCC. Now for the positive half cycle of the input signal, transistor T1 is on and T2 is off, and therefore it conducts a current IC1 in the direction shown, due to which the output voltage through the transformer TR2 is obtained in opposite direction as shown here. And similarly, for the negative half cycle of the input signal, transistor T2 is on and T1 is off, and therefore we get a negative half cycle magnified. So this is the push-pull transistor configuration, push-pull amplifier configuration. So with the help of the two transistors T1 and T2 and the two transformers, we get the output voltage which is obtained for the full cycle of the input signal. So we are having both the benefits, that we are using Class B power amplifier which offers the efficiency of 78.5%. Along with that, we get the full cycle at the output. So this is how the two transistor conducts. Transistor 1 conducts for conduction of A, showing conduction A, and the transistor 2 is showing conduction of B. And since the two transistors cannot be perfectly or ideally matched, so there is a time difference or time gap between the conductions of T1 and T2, which gives rise to a specific kind of distortion called crossover distortion. But before we go to that, let us talk about its power conversion efficiency, which is P out AC upon P in DC, where P in DC is given as twice of IC max into VCC upon pi, and RMS value of IC is IC by root 2, and similarly RMS value of the output voltage is VCC by root 2. So if we get the P out AC, it is Vrms into Irms, where Irms is IC max upon root 2 and Vrms is VCC by root 2, and it is IC into VCC upon 2. So if we put the values of P out AC and P in DC in the overall efficiency formula, we get eta factor equal to 78.5%. So this is the biggest advantage of class B push-pull power amplifier. This is showing another configuration which is called as the complementary symmetry push-pull power amplifier, having one PNP and one NPN transistor. So here are few advantages and disadvantages of class B push-pull power amplifier. The advantages are that as there is no need of set-type transformers, the weight and cost are reduced. And the second advantage is that equal and opposite input signal voltages are not required. The disadvantages are that it is difficult to get a pair of transistors NPN and PNP which have similar and identical characteristics. So it is very difficult to have the identical transistors. And secondly, both transistors require different polarity of voltages, which is positive voltage and negative voltage. So because of that, it has got a lot of disadvantages also. Thank you so much.